So we are going to do this as a screen capture. It's an animation which is going to show us the tide view. So here we are looking at the lunar tidal bulges, is obviously the idealized case again, where the moon is on the equatorial plane and we are looking at the aquaplanet. So you have two bulges on either side. So if we look at the cycles, then obviously the Earth is rotating. So we are looking down from the one of the poles, and as the moon moves and Earth rotates through the tidal bulges, right? So you saw that you end up with the first quarter moon here. So the tidal bulge is following the moon. So you have two bulges on either side. Obviously they are not going to be as strong as the full moon if the solar tidal bulges are going to have destructive interference, right? Because now we have also added the solar tidal bulge here. So sun is somewhere here, sitting on the far right here, producing his own tidal bulges on the other side. So this we called the quadrature, right? So the sun and the moon are at 90 degrees, so you have destructive interference between lunar and solar tidal bulges to produce small tidal range. Now we go from first quarter to new moon. So we went from full moon to first quarter, and you can see the tidal bulge. The sun is not moving. This is on a diurnal time scale or monthly time scale. So we went from first quarter to full moon. So moon is on the other side, so reflecting sun's light. So we can see what we call the full moon. So now you have constructive interference between the lunar and solar bulges, as we saw before. So you have the two bulges, the lunar and the solar bulges on either side, interfering with each other constructively, which means what? We are going to get spring tide. Up here we got the neap tides, as we will see again. So we go from full moon to the third quarter moon. So again, sun is sitting there. Solar bulge is going to be again in quadrature with the lunar bulges. Okay, third quarter moon. So we went from new moon, first quarter, full moon, third quarter. If I said it wrong, you correct it. So again, in quadrature, another destructive interference, so neap tides, and then you complete the cycle by going back from the third quarter back to the new moon and syzygy, or constructive interference between the solar tidal forcing and the lunar tidal forcing. You can add the charts to go with it. So you can see here the high tides, low tides. Again, this is idealized, so you can see the spring tide has high range. The tidal range decreases continuously to the first quarter, and then as we go from the first quarter to the full moon, you hit the neap tide at the first quarter, destructive interference. Tidal bulge begins to increase. You get another spring tide, 12 hours, and should be 14 hours, 14 days, 18 hours. Sorry, you have to remember the days of the moon's orbit around the moon, around the Earth, and the time of the day, right? So again, another spring tide, and back to the third quarter, and then back to the full moon, right? Great animation, but nonetheless, I mean it in a cynical way. So we are at the neap tide and back to new moon and the full tide. So this should just at least give you a sense of how Earth is moving through the bulges when we have idealized tide. But as we saw, when we add continents, we're going to have amphidromic points and co-tidal lines and so on. So one 29.5 day lunar cycle is shown in this animation. Remember, the perigee apogee was 27.5, but one lunar cycle is 29.5 days. I didn't mention something called the blue moon. Because the lunar cycle is 29.5 days, and we have arranged the calendar arbitrarily as 30 days, 31 days, and the leap year, and so on. 28 days for a leap year, 29 days for a leap year, and 28 days in February for normal years. You can end up with 2 full moons in one calendar month. That's called a blue moon. It's unclear why the name blue is given, but nonetheless, it's rare. But how rare? Every 2.73 years, you end up getting 2 full moons in one month. So a blue moon happens just about every 3 years. So it's not that rare. Okay. So you also get the super moon when the moon is at perigee and it's closer to the Earth and looks 30% bigger, and so on. So I didn't say these things in the lecture, but now you know, right? So that's the animation. That concludes this chapter. It's fairly straightforward. We are not going to use it much more in the rest of the course, but it's good that you're exposed to it, because you might end up working on satellite data, sea levels, and so on, modeling the tide, predicting the tide, etc. So you never know when it's going to come in handy, right? See you in the next chapter.